Have you ever looked up at the night sky and felt a sense of wonder? A feeling that everything, from the smallest grain of sand to the most distant star, is connected by a hidden set of rules. This was the world of Pythagoras. Born on the Greek island of Samos around 570 BC, he wasn't just a man who liked triangles. He was a philosopher, a mystic, and the leader of a movement that saw the entire universe as a grand symphony, a beautiful piece of music played on the strings of mathematics. He believed that numbers were not just tools for counting, they were the very essence of reality itself, the fundamental building blocks of everything we can see and touch. Pythagoras grew up in a world brimming with new ideas. His father, Menisarchus, was a merchant, which likely gave the young Pythagoras exposure to different cultures and ways of thinking from an early age. While details of his family are sparse, it's clear he was born into a position that allowed him to pursue an education, a luxury not afforded to everyone. He was a seeker of truth from the very beginning, driven by an insatiable curiosity. His core belief that all things are number was revolutionary. It suggested that the cosmos wasn't chaotic or random, but was governed by a logical, understandable order, an order that could be revealed through the study of mathematics. This fundamental idea set him on a path that would change the course of human thought forever. He saw mathematical relationships in everything. He looked at the heavens and saw the planets moving in predictable orbits, a celestial dance choreographed by numbers. He listened to music and discovered that the pleasing harmonies we enjoy are based on simple numerical ratios. This connection between the abstract world of numbers and the physical world we experience was his great insight. For Pythagoras, mathematics was more than a subject. It was a spiritual path, a way to understand our place in the cosmos and achieve a deeper harmony with nature. This profound belief that the universe could be understood through reason and logic was a radical departure from the purely mystical explanations of his time. It was a spark that would ignite the flame of scientific inquiry for centuries to come. The idea that everything, from the shape of a flower to the motion of the stars, could be described by a mathematical equation is a cornerstone of modern science. And it all started with this one man from Samos, who dared to believe that numbers held the secret key to unlocking the mysteries of the universe. He wasn't just doing math, he was trying to read the mind of the cosmos itself. To build his grand vision of a numerical universe, Pythagoras knew he had to learn from the great civilizations of his time. His quest for knowledge was not confined to the shores of Greece. As a young man, he embarked on an extraordinary journey, a grand tour of ancient wisdom that lasted for more than 2 decades. He was like a cosmic traveler on our own planet, seeking out the brightest minds and the oldest traditions. His travels took him to the land of the pharaohs, Egypt, a civilization that had already existed for thousands of years. There, he immersed himself in the knowledge of the Egyptian priests, who were masters of geometry. The Egyptians had developed practical geometry out of necessity. They needed to precisely survey and redivide the fertile lands along the Nile River after the annual floods washed away property boundaries. Pythagoras studied their methods, learning how they used ropes with knots to create perfect right angles and construct their monumental pyramids with astonishing accuracy. He absorbed their understanding of area and volume, but he saw something more. Where the Egyptians saw practical tools for construction and agriculture, Pythagoras saw the underlying principles, the abstract truths of geometry that existed independently of any physical application. This was a crucial step in his intellectual development. His journey didn't end in Egypt. The search for wisdom led him further east to the powerful empire of Babylon. In the bustling cities of Mesopotamia, he encountered astronomers who had been meticulously charting the heavens for centuries. The Babylonians were skilled mathematicians who had developed sophisticated algebraic techniques and had compiled vast catalogues of astronomical observations. From them, Pythagoras learned about the patterns in the movements of the planets and stars. He was exposed to their advanced number systems and their understanding of astronomical cycles, knowledge that would later influence his own cosmological theories about the harmony of the spheres. After absorbing the wisdom of these ancient cultures, Pythagoras returned to his world, his mind overflowing with new ideas. He had synthesized the practical geometry of the Egyptian and the astronomical mathematics of the Babylonians into something new. His travels had transformed him from a student into a master, equipped with a unique and powerful perspective. He had seen that different cultures had discovered pieces of the same puzzle. Now, he felt it was his destiny to put those pieces together and reveal the complete picture of a universe governed by the elegant and unchanging laws of mathematics, a cosmos waiting to be understood. Around the year 530 BC, Pythagoras settled in Croton, a thriving Greek colony in what is now southern Italy. It was here that he established his famous school, which was much more than a place of learning. It was a community, a brotherhood, and in some ways, a secret society. The followers, known as Pythagoreans, lived a structured and disciplined life together. They were bound by strict rules of loyalty and a vow of silence, especially concerning the school's mathematical discoveries. The group was divided into two tiers: the acousmatikoi, or the listeners, who learned the basic rules and beliefs, and the mathematikoi, the learners, who were initiated into the deeper secrets of mathematics, philosophy, and science. Within the inner circle of the mathematikoi, learning was a profound journey. The curriculum was broad, covering what would later be called the quadrivium, arithmetic, geometry, music, and astronomy. They believed these four subjects were interconnected, revealing the numerical harmony of the cosmos. Students explored the properties of numbers, classifying them into categories like odd and even, prime and composite. They investigated geometric shapes and solids, seeking the perfect forms that underpinned the structure of the universe. It was within this secretive and intellectually charged environment that a famous discovery was credited to their leader: the Pythagorean Theorem. The Pythagorean Theorem is a simple yet incredibly powerful statement about right-angled triangles. It declares that if you take the lengths of the two shorter sides, let's call them A and B, square each one, and add those squares together, the sum will be equal to the square of the longest side, the hypotenuse, which we'll call C. So, a squared plus b squared equals c squared. Imagine a triangle with shorter sides of 3 units and 4 units. If you square 3, you get 9. If you square 4, you get 16. Adding them together gives you 25. The theorem tells us this is the square of the hypotenuse, and the square root of 25 is 5. So the longest side must be 5 units long. This elegant rule connects geometry and arithmetic in a beautiful, undeniable way. The school's beliefs went far beyond geometry. The Pythagoreans were fascinated by number theory. They studied triangular numbers, 1, 3, 6, 10, which could be arranged into equilateral triangles, and perfect numbers, whose divisors, excluding the number itself, add up to the number, like 6, since 1 plus 2 plus 3 equals 6. They believed that numbers had mystical qualities. For instance, the number 10, the tetractys, was considered sacred because it was the sum of the first 4 integers. 1 plus 2 plus 3 plus 4 equals 10. All discoveries were attributed to Pythagoras himself, reinforcing his godlike status within the community, even if they were made by his students. This practice makes it difficult for historians today to know for sure which ideas originated with the man and which came from his brilliant followers. Pythagoras' influence echoes far beyond the famous theorem that bears his name. He was one of the first to build a bridge between the world of mathematics and the world of music. The story goes that he was walking past a blacksmith shop and was struck by the harmonious and dissonant sounds of the hammers striking anvils. He investigated and discovered a stunning truth. Musical harmony is a direct result of simple whole number ratios. For instance, he found that if you pluck a string and then pluck another string that is exactly half its length, the second string produces a note that is 1 octave higher. The ratio of 2 to 1 creates a perfect octave. A ratio of 3 to 2 creates a perfect fifth, another pleasing consonant sound. This discovery was monumental. It demonstrated that something as ethereal and subjective as musical beauty was governed by the cold, hard logic of numbers. This led to his grander theory of the harmony of the spheres. Pythagoras and his followers imagined that the sun, moon, and planets, as they moved through the heavens, also produced a kind of music. A celestial hum that was inaudible to human ears but was perfectly harmonious. Each celestial body, based on its orbital distance, contributed its own note to a divine cosmic symphony. This idea that the universe is not silent but filled with a mathematical music inspired astronomers and thinkers for nearly 2,000 years, including Johannes Kepler. The Pythagorean school had many unusual rules and beliefs. They were vegetarians, believing in the transmigration of souls or reincarnation. They thought that a human soul could be reborn into an animal, so eating meat was akin to cannibalism. They also had strange prohibitions, the most famous of which was a strict rule against eating beans. The exact reason is lost to history, but theories range from the bean's shape to the belief that they contained the souls of the dead. These mystical elements were inseparable from their scientific pursuits. For the Pythagoreans, seeking mathematical truth was a way to purify the soul and bring it closer to the divine harmony of the universe. Today, Pythagoras is remembered as a foundational figure in the history of science and philosophy. While his school eventually disbanded and many of his writings were lost, his ideas were preserved and expanded upon by later thinkers like Plato and Euclid. The Pythagorean Theorem remains one of the most fundamental principles in all of mathematics, essential for everything from architecture and engineering to navigation and computer graphics. Every time we use GPS, design a building, or even play a video game, we are using the legacy of his discovery. Pythagoras taught us that the universe speaks in the language of numbers, and his work gave us the first few words of